All right, hey class. Lesson 8. Yeah, all right. So let's do lesson 8. Um, and let's get into it. These were the example problems. So I think I did them in class already. So I won't do them. No, I won't do them. I will at least point out again for anyone who might have missed it that this is a typo here. It shouldn't be sine, cosine, sine, sine. That's not the right form for any of our identities. It needs to either be cosine, cosine, sine, sine, or sine, cosine, cosine, sine. So somewhere there's a typo. And we did discuss in class that if I changed this to cosine and made it sine, cosine, cosine, sine, then that's the expansion of a sine. And if we leave this a difference, then it's the expansion of the sine of a difference. But then we'd end up doing sine of the 40 minus the 50. That would turn into the sine of negative 10, which just is not evaluatable at all. So you're being asked to do two things here. It says write in terms of one expression. So if all I was asking you to do is just to collapse the thing down and write it in terms of one expression, then great, we did do that. But it does go on to say, now find the expression's value. So to find the expression's value, well, we can't. Using negative 10, there's no unit circle values we could use that would give us negative 10. There's kind of no way to get there from here. So I'm saying that's just not it. So I think the typo is that we want to just make sine here into cosine. Then this problem is doable. Now that we're in it, I'm just going to do it. Now that it's cosine, cosine, sine, sine, it's a cosine expansion. And if it's a minus, then it's a plus. And 40 plus 50 is 90. So this whole expression is just the same thing as the cosine of 90. And again, 90 degrees on the unit circle would put you here. Cosine is the x-coordinate, so cosine of 90 is 0. And that's it. I'm not doing 2. We'll move on into the homework problems. Again, I know it says classwork here, but be treating this as your homework. Pretend it says homework. And you're supposed to be doing the evens, I said. Wouldn't kill you to do some of the odds too if you need the practice, but I am just going to do the evens, I guess, since that's what we said. So I'll bring this guy over. We'll forget about number 1, and we'll do this one. So okay, again, like I said, we want to collapse these down. And if I see cosine, cosine, sine, sine, then that form is the expansion of a cosine identity. If I see a minus, then it must be the expansion of the cosine of a sum. And the two angles are negative 145 and positive 160. So if I'm adding those up, I get cosine of 15 degrees. And so actually right away, it kind of feels like we're bumping into the same problem because, okay, I got cosine 15. That's another expression that's not on the unit circle, so I can't evaluate it, right? Except yes, you can, because don't forget, lesson 6 and lesson 7. We do actually know how to do this, and what we do is, I know we just worked to collapse this thing back down to just a single expression, but now we got to expand it out again to cosine, cosine. And the thing is, this time we got to choose our angles more wisely. So the original expression used negative 145 and positive 160, and those weren't evaluatable expressions. I don't know what that is. But to get the 15, we can just break this down. We could do this as just the sum of the 30 and the 45. And I don't know if it makes sense for me to do this again since we've done this exact one before. But sure, one more time, we'll do it again. In case you guys are tuning into this video, but you didn't tune into the others. Cosine 30 is root 3 over 2. This is root 2 over 2. This is 1/2. This is root 2 over 2. So you're looking at root 6 over 4 minus root 2 over 4, which is root 6 minus root 2 over 4. And why does that not feel right to me? We're doing it as a sum, so it should be a difference. Oh no, we're not doing it as a sum. We're not doing it as a sum. My bad. I kind of skipped a step here. Alright, this should have been cosine of the 45 minus the 30. And so since we're doing it as a difference, it should be a sum. And then technically this is out of order, I guess, but it doesn't matter because it's multiplication. But it should be cosine 45, cosine 30, sine 45, sine 30. But we'll get the same thing. Okay, but at least I caught that. It definitely does have to be a sum. Again, if you're wondering how I knew I was wrong, I did explain in the other videos that by now we probably should have somewhat of a sense of what these things should be worth. So 15 degrees, that's a super shallow angle. So if you sketch this out, you can tell that if we make a triangle again, we should be talking about a pretty long x coordinate and a short y coordinate. And I know that, okay, that means I should be getting the biggest possible value I can from a root 6 and a root 2. So root 6 minus root 2, that's not the biggest possible value that I could get. And for 15, I want the biggest possible value I could get. So I knew it had to be a sum. And that's how I knew I screwed up. And then I was able to go back and fix it. So anyway, my bad. I apologize. Let's move on. We're doing 4. I'm not doing 3. Although, you know what? I'll mention 3 because I had at least one person ask about it. But, you know, it doesn't matter that you've got the same angle twice. It's no big deal. You would still recognize this as the expansion of a cosine. The plus implies that it's the cosine of a difference. And that's alpha, that's beta. That's alpha, that's beta. So I guess we're doing 140 minus 140. So this expression should have the same value as the cosine of 0. 0 just being right here. So that should be 1, because cosine is the x-coordinate. So that guy's doable, even if it's a little different. All right, now 4 is where we had to do a little wrangling. So we talked about this problem in class, and we talked about how since this one is negative and this one is positive, we can't actually say that this is alpha, this is beta. So I'm fine with beta. Beta is pi in both instances. But here alpha is negative, and here the alpha is positive, and that's actually not okay. We have to actually resolve that. So basically we had to resort to symmetry identities. So looking at this, the sine of negative 3 pi over 2. You could literally just plot that point. Negative 3 pi over 2 would revolve us clockwise. 270 degrees, it would plot us in that position there. The cosine of 3 pi over 2, or positive 3 pi over 2, just where would that be? It would rotate us over to here. And so what you can see is sine here. Well, the sine of the negative angle is giving positive 1, but the sine of the positive angle is giving negative 1. So we can see the exact relationship in the identity that we found, which is that the sine of the opposite of an angle, it's not equal to the sine of the angle itself, it's equal to the opposite of the sine of the angle itself. So what that means is I can just take this negative sign away, but it'll generate a negative sign on the whole expression. And we already have a negative as well. So this is a lot of negatives getting thrown around, I know. But to simplify this first sign factor, would go negative. We'll go ahead and change this angle to positive 3 pi over 2. But by removing the negative from the angle, it's going to now be the opposite of what it used to be. So I need a negative in front of it now. So there'll be negative sine of positive 3 pi over 2. Now the sine of pi was fine, no big deal. Cosine of 3 pi over 2 is fine, especially now that it's the same as the other one, in cosine pi. So of course, now here the negative and the negative will cancel. So those cancel out. But this is still not quite right because our expansion, we never had an expansion that was sine, sine, and then cosine, cosine. Our expansion goes cosine, cosine, sine, sine. So we have to switch the order. So this whole thing, we're going to move it to after the subtraction. This whole thing, we're going to move it to before the subtraction. And no, you're not allowed to just do that. We have, again, another situation where by doing that change, we end up with the opposite answer that we used to have. So that generates a negative sign too. So the act of flipping the order of these things around the minus sign means we're now getting the opposite of what we should have gotten. So this will be 3 pi over 2, and then cosine of pi. This is still minus, we're just flipping around it. We're doing the sine of 3 pi over 2, sine of pi. So now we can finally just collapse this expansion. It's cosine, cosine, sine, sine, so it must be the expansion of a cosine. It's a difference, so it must be a sum. And my two angles in question are 3 pi over 2. And can I just jump right to saying that pi is going to be 2 pi over 2? Because we're going to need that common denominator. So we can now see that this original expression up here is now going to be the opposite of the cosine of 5 pi over 2. And that's good. We could maybe do a little better though, because where's 5 pi over 2? 5 pi over 2 would be what? 1 pi, 2 pi, and then an extra pi over 2. Right? 5 pi over 2 is just 4 pi over 2. That's 2 pi, plus an extra pi over 2. So for sure, our angle, 5 pi over 2, is this angle. We rotate all the way around, and then 90 more. So what's the cosine of that? Cosine is x. Then this whole thing is 0 anyway. So this negative sign is kind of a moot point because negative 0 is, well, 0. So that's it. Do I point this out? Yeah, sure. Let's point this out. I don't know if maybe we should feel silly doing all this math anyway because the expressions they gave us in the first place were evaluatable. Like, we all should have known that the sine of pi was 0 anyway. The cosine of pi was 1. But what's the cosine of 3 pi over 2? 3 pi over 2, remember, is this blue position here. Cosine is x, so that's 0. So right away you can see this whole first term goes to 0 because the sine of pi is 0. And this whole second term goes to 0 because the cosine of 3 pi over 2 is 0. So this expression from the get-go was 0 minus 0, which was 0. So we just jumped through a lot of hoops to do what we actually could have done in the first place. I will point out to you though, part of the problem was getting to here. Part of the problem was rewriting the expression as a single trig function evaluated at some relatively clean angle. So that expression was important. The final value was important. And let's do 6. Oh, there is no 6. Okay, that's it. So that's apparently all you get for practice on questions like these. Fine with me. I don't know. Probably tomorrow I'll push out a few more practice problems that you guys can do. A little bit of everything from 6, 7, 8, 9. And so if this wasn't enough for you, there's a couple more odds, or are there? I mean, I think I didn't do 1. Maybe you can go back and do 1. But I don't know. I hope that you find this easy enough that you don't really need more. But as I say, I will try to give you a few more tomorrow anyway. Anyway, as always, I hope that this helps you. And tune in for the next one. I'm going to record and post the next one right now. So see you later.